Assalamualaikum, my name is Putra Al-Zafran Lim and my matrix number is 33 DPC 20F1039.
Okay, my name is Muhammad Nazir bin Razani. My matric number is 33 DPC 20F1046. I am from DPC3C.
My name is Muhammad Anas bin Muhammad Azman. My matrix number is 33 DPC 20F1041. I am from class DPC3C.
For our mini project this year, we were given multiple tasks to analyze the three-phase separator training unit to test our Pnid knowledge so far. We headed to the B6 laboratory in groups of 4 to work as a team, breaking down and analyzing this training unit as much as we can. With the guidance and supervision of Puan Hatini, we eventually were able to figure out the process of this piping mechanism and workflow. To have a better understanding of the process, we split up and sketched the workflow and also take pictures of the equipment and instrument of the training unit, because doing this alone would take a very long time. We had to come in a second time to make confirmation for the processes, piping flow, and equipment just to make sure we didn't leave any important unit behind. After the final sketch is complete, we handed the sketch to Puan Hatini to check our work. Once the sketch is approved, we can finally proceed to the next step of this project, which is the Pnid drawing in AutoCAD Plan 3D. For B, we need to explain how we draw the Pnid for our project. Firstly, we need to set up our AutoCAD. First of all, we need to open the AutoCAD Plan 3D application in our laptop. It might take a while for it to fully load the data, making sure it can run smoothly. Once the application is ready to be used, we will go to the project manager and select New Project. Then, we need to name our project, which in this case, three-phase separator. And we need to specify the directory for our program generated files to be stored. Then we click Next. For the unit of this drawing, we will select Imperial Unit as the base unit in this project. Selecting Imperial Unit will set our units to inches, and we hit Next. For the Pnid Symbology Standard, we will use ISA, and we hit Next. We will stay as single user local database. Then we will click Finish in the project setup wizard. Once it is finally done, we will go to the three-phase separator Pnid drawing, and we will right click and we will select New Drawing, and we will put the file drawing name. And we will click OK. After that, it will redirect us to a new drawing. which can be seen in this screen. Once the setup wizard is complete, we can finally start our PNID drawing. We will start the piping line from the Christmas tree seen on the upper left side. Then we will draw the two field-mounted instruments along the pipeline, labeling TT103 and PT105 respectively. This instrument can be found on the tooth pallets over at Instruments, and there we can see a field discrete instrument. Then we will draw a check valve and label it CV102. We will go over at valves, and there we can see the check valve. Then we will draw the shutdown valve with a solenoid actuator and label it SDV108. And there we can see the control valve, and we just changed the actuator to solenoid. Then we will draw a ball valve, label it MVB104. We will use the globe valve and change the circle to a transparent one. Then we will draw a vessel tank and name it as a separator vessel. We will simply go to Equipments, and there we can see the vessel. We only have to rotate it 90 degrees to make it horizontal. On top of the vessel, we will draw a ball valve MVB106 and a pressure safety valve PSV107. This can be looked at the angle valve. We only have to put the signal on top of it, indicating it's a pressure safety valve. Then the line will be heading to the opposite side of the vessel, where a blow down valve BDV110 is drawn at the back of the vessel. Then we will draw a ball valve, and then we will draw a level transmitter and label it LT110, and the following instrument is LI110, and then an electrical signal is drawn to an emergency shutdown ESD, reconnecting it to the shutdown valve, making it a loop. Also on top of the vessel, a ball valve is drawn. Label it MVB120. Beside it, a pressure gauge is drawn with the label PG110. After that, we will draw two instruments, PT106. On top of it is PI106. Then an electrical signal is followed to an emergency shutdown ESD, then reconnecting it to the blow down valve that we draw earlier. This blow down valve is simply a gate valve with a solenoid actuator. Then below the vessel, we will draw a ball valve MVB300, where indicates water drain. We will draw a level transmitter and label it LT107, then reconnecting it back to the vessel. And here is the ball valve that I said earlier, MVB 300, that signals water drain. Both level gauge LG108 and LG109 will be drawn below the vessel. That is all from me, Putra. Now I will hand you to Nazrin, where he will explain the process from the vessel to the water tank. Thank you.
Okay, my name is Muhammad Nazrin. Okay, I will talk about vessel to water tank. A pipeline will exit out the vessel and branch out a check valve CV504 is drawn one on one of the branch and a pump P503 is also drawn. The other branch, a shutdown valve with a solenoid actuator SDV301 is drawn. The pipeline from the pump is reconnected to the this branch. After that, a ball valve MVB301 is placed here. Then a flow transmitter FT301 is drawn here, and two other ball valve MVB304 and MVB305 respectively is drawn. A flow check valve FCV302 is drawn with a ball valve MVB310 is drawn looping around the flow check valve. Lastly, a ball valve MVB307 is drawn before ending it. Lastly, the ball valve MVB307 is drawn before ending it to the water tank. Above the flow transmitter area, we will draw a flow indicator FI301. Then an electrical signal line is drawn to a flow indicator controller FIC301 and to a flow transducer FY301. The level transmitter from the vessel is connected to the shutdown valve through an emergency shutdown with an electrical signal. After the transducer, a pneumatic line is drawn, reconnected it back to the flow check valve, completing the flow control loop for the water pipeline. Thank you.
Okay, my name Muhammad Anas. I want to talk about vessel to oil tank. From the vessel, a pipeline will easy out and branch out, and a ball valve MBV 200 is placed here, indicating the oil drain. From the other branch will also branch out into two pipelines that contain a pump P503 that will eventually reconnect to the other branch. Then a shutdown valve with a solenoid actor SDV201 is drawing along with a ball valve MBV201, a flow transmitter FT201 and two ball valve MBV204 and MBV205 respectively are drawn along the pipeline. A flow check valve FCV202 and a ball valve MBV207 is drawing next. After FT201, a pipeline will branch out with a check valve CV404 and ball valve MBV210 drawn is this pipeline before reconnecting to the main pipeline, then entering the oil tank. At the FT201, there will be a flow control loop consisting of flow indicator FI201 connected to the flow indicator controller with an electrical signal before reaching the flow transducer FY201. The flow transducer is then connected back to the FCV202 with a pneumatic signal. After you done with a drawing, save the drawing as a DWG format and PDF format. Thank you.
As the conclusion, analyzing this training unit was not an easy task. A lot of effort, studying, and confirmation were made from this mini project. This clearly shows that this subject has a lot to offer in terms of the field of knowledge and the practical benefit it brings in our future studies or work field. But this training unit is a very good example of a stepping stone before we encounter our next big project in the future that serves as a warm-up. We also successfully able to transfer the entire three-phase separated training unit to a presentable PNID drawing. Every single equipment and instrument are able to be in this drawing with detail about its workflow. What we have learned in this piping and instrumentation diagram is not an easy subject but a very hard one. But with exposure to the real project, it serves as a great introduction before we enter our feet into the real experience outside the institution, facing real problems in our careers based on this particular subject. Thank you very much for listening, and I hope you enjoy our presentation.